Hi, today we're going to talk about geometric series and sequences. So we already kind of talked about arithmetic series and sequences and how that was taking a list of numbers and adding a constant term to each one to get the next. And so now we're going to talk about what happens if you have a list of numbers in which the relationship between each consecutive term is you multiply by a common ratio, a common factor to get to the next one. And so what I mean by this is what happens if you had 0.5, the list 0.5, 2, 8, 32, and so on. This would be a geometric series or sequence because you have a multiplication by 4 here, a multiplication by 4 here, and a multiplication by 4 here, and it's implied that you would continue this along this sequence. And so we have a common ratio of 4. And so how do we construct the equation, the formula for an arbitrary term a sub n for this sequence? Well, first we're going to take the first term, a sub 1, and then we're going to multiply it by this common ratio. In this case it's 4, but we'll just call it r in this case. And to get the nth term, we're going to multiply a sub 1 by r n minus 1 times. And this makes sense because if you want the first term, you're going to plug in a 1 here, and so you're going to get r to the power of 0, and anything to the power of 0 is 1, so we'll get a sub 1 equals a sub 1, so that makes sense. If you want a sub 3, you're going to plug in 3 right here, and you're going to get a sub 1 times r squared. So you multiply by 4 to get the second term, and then again to get the third term. So this makes sense. What would happen if you had 1/9, 1, 9, 81, and so on? What happens if you had that? Well, as we can see here, you're multiplying by 9, and then by 9 again, and then by 9. So our common ratio is going to be 9. So our r is going to equal 9. And our a sub 1 is going to equal 1/9. So now we can build our equation. A sub n, let's write that a little bit neater. A sub n equals 1/9, or a sub 1, times r, and our r is 9, so 9 to the power of n minus 1. Likewise, I guess we can finish off this problem here. If we were to write the sequence term for this right here, you go a sub n is equal to 0.5 times r, and we know that r is 4, so r to the power of n minus 1. So this would describe this sequence right here. Let's think about how we would go about adding all these numbers up. So we need a whole new equation for geometric series, and it starts with s. S is the sum, sub n, and n is the number of terms that we want to sum up, equals a, the first term that we want to add together, times the quantity r, our common ratio, to the power of n, the number of terms that we want to sum up, minus 1, divided by r, common ratio, minus 1. And so this will be our summation equation. So let's try an example. What happens if we wanted to sum from k equals 3 all the way up to 10 of the geometric series 4 times 2 to the power of k minus 1. So we want to sum that. So where would we start? First we want to find our first term. And our first term is going to be at k equals 3. So we plug in 3 here, we get 4 times 2 squared. And so 2 squared is 4. 4 times 4 is 16. So a equals 16. It's the first term that we are summing up. Not the first term, but the first one that we're summing up. And so next we want to find r. R is our common ratio, the term that we are multiplying each term by to get in the next. So that is going to be 2. An easy way to see this is because 2 has the exponents attached. And so n. N is kind of tricky because you want to look at this and say 10. Or at least you want to go 10 minus 3 is 7. But you have to take into consideration that you're actually including the term where k equals 3. So we're actually including this term, so the term that we would be leaving out, the first term that we would cut out would be 2. So 10 minus 2 would be 8. And so we have all of these right here. And so now all we need to do is plug these into our formula here. And so if we go up here, our S sub 8 is going to equal A, which is 16, times quantity r to the power of n minus 1, so 2 to the power of 8 minus 1, divided by 2 minus 1, just 1, simple. So we get 16, and let's see, 2 to the power of 8 would be 32, 64, that would be 256 minus 1 over 1, I guess I didn't need to put that, but equals 16 times 255, and so if we multiply this together, 255 times 16, we're going to get, wait for it, this is very dramatic, 4,080. So that would be the sum.